Hello, good day viewers. Still on fundamental theorem of calculus. In our previous lesson, we have solved problems in the form of d over dx of the integral from a certain constant to x, where x is a region between a down to b, right? Of the function f of t dt, where we say this is exactly equal to f of x. What I told you, sometimes the boundaries might be different from a constant to x. It could be from a certain function to another function. For example, you can see we have from 2x down to x squared, from sine x to cosine x, from 0 to 2x. So if you have a problem like this, where you have from a, which is a constant, to only x, you can simply evaluate it to f of x. But in a situation like this, we have to apply the formula I derived yesterday. So let's use it. Remember, I told you, if you have d over dx of the integral from a certain function a of x to another function b of x of the function f of t dt, I told you this is the same thing as substituting b of x, which is the upper limit, into the function that is f of b of x. Then you multiply by its derivative, that is the upper limit, b prime of x. Subtract. Substitute the lower limit, that is f of a of x. Multiply by its derivative, that is a prime of x. Simplify and get your final answer. All right, let us apply this formula into this and that. Because I told you sometimes the function might be very difficult to integrate. I think from all of these three functions, this is the simplest function to integrate. But this and this will be very much difficult to integrate. All right, so let's start with the first one. This is the same thing as substituting the upper limit into the function t. So this becomes e to the, instead of t squared, we have the whole of this x squared also squared, right? Then I told you to multiply by its derivative. That is, if you differentiate x squared, you have 2x. Then you subtract. This time around, you substitute the lower boundary, which is 2x. That is e to the 2x, but whole squared because t has a power of 2. Then multiply by its derivative. The derivative of 2x is 2. Then you simplify. I can bring 2x to the back. We have 2x. E to the what? X squared whole squared is x to the power of 4. So this is x to the power of 4. The minus, these two can multiply e to the 4x squared. And hence, this is said to be the solution to the first problem. Then moving down to the second problem. So the second problem, we would like to evaluate d over dx of the integral from sine x to cosine x of the function t squared with respect to t. This is a very simple function to integrate. You can do that. Integrate this, substitute the upper and the lower boundary before you differentiate the result. But I'm not going to do that because we have demonstrated that yesterday. So instead, we are going to substitute the upper limit into the function t squared. So we have what? Cosine x squared, because cosine x is replacing t. So this is t squared, so we will be having cosine squared x, right? So this is cosine squared x. Then multiply by the derivative of the top. Once you differentiate cosine x, you are going to obtain negative sine x. So we have negative sine x. Then you subtract, you take the lower limit, which is sine x. So it will be going to be sine squared x. Multiply by its derivative, which is going to give us cosine x. Simplify. This is negative sine x cosine x. Negative sine x cosine squared x, I mean. The minus sine squared x cosine x. This is the result. Then moving to the last one. Let me see if this space will be enough for us, or I can do that right here to the bottom. All right, let me do that here. Since we have a constant to the bottom, do not pay attention to the bottom. But if you like, you can substitute it. We take the function which is the square root of, that is the problem number 3. We take square root of 1 plus e to the t squared. But that t will be replaced with 2x. So this will be 1 plus e to the t, which is 2x squared. Should I expand it directly? Because if t is 2x, you see 2x whole squared will give us 4x squared. So I can write it directly here as 4x squared. Then you multiply by its derivative. The derivative of the top is what? 2x. Sorry, 2. Because the function is 2x. If you differentiate it, you get 2. So I can bring the 2 to the back here. 2 multiplied by the square root of 1 plus e to the 4x squared. Then you subtract. This time around, you substitute 0 into the function. So it will be 0 squared is 0. So you have e to the 0 is 1. 1 plus 1 is 2. So the whole of this will be square root of 2. But even if you write square root of 2, remember to multiply by the derivative of the bottom, which is constant, and derivative of constant is 0. So multiplying by 0 will make the whole of this equal to 0. This is why I say you don't have to pay attention to the bottom. So finally, this is just equal to, or should I write it here? The whole of this is equal to the square root of, okay, 2 multiplied by 1 plus e to the 4x squared. 4x squared. This is the solution. But if you think you can integrate this function, substitute these boundaries 0 to 2x. Whatever you obtain, differentiate it. You must get this function. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.